function. Right, we'll look into some examples now so that it will make clear for you guys. So in this first illustration, I have taken two functions. This is a simple case. You can see here that for function f, the domain is a set of real numbers, and also the codomain is a set of real numbers. For function g, the same set of real numbers for the domain and set of real numbers for the codomain. Now, what is the criteria that is needed to be satisfied? If you want to define function g by f, you know that the range of the function f should be equal or a subset of the domain of g. This is the criteria. Now let's see if this happens. Now you can see here that the range of the function f is equal to the domain of the function g, because here the domain is the set of R and the range will be also the set of R. Look at this example. The function rule is 2x plus 3. This is a straight line. From early examples, you know that for straight line the range is equal to the codomain. For a straight line, the range is equal to the codomain. Therefore, the range of the function f is equivalent to the domain of the function g. Therefore, g of f or g by f exists. That's why I put a right sign there. Now, how do you define? Now, let's say the rule is defined as for f of x. Now, for a composite function, when you define the rule, you have to define it in this way. Within parentheses, you write g of f. Within parentheses, you write g of f or g by f. Then you write the input x, right? This will be the function, and this is the argument of the function. So you can simply write it. This is equivalent to g of f of x. G of f of x. It is like the function g is eating the function f of x. Now, for function g, what is the rule? The rule here being g of x is equal to x minus 1. So x is the input here. Now, what you have to do is you have to replace x in the function g by the function f of x. Now you can see here, I think you have done several examples on this without knowing what a composite function is. So earlier it was x minus 1. Now for x you have to put f of x. So I have written here 2x plus 3 and you have minus 1. The answer is 2x plus 1. So this is g by f. This is the rule that connects domain and any element from the domain of function f to the codomain of function g. Right? This is the rule that connects it. You can see here the rule says 2x plus 2. If we have input x, the output will be like twice of x plus 2. Now let's see if g of f exists. F of g exists. In this example, so the g will become the first function and f becomes the second function. Since this is the simplest example, you can see here that the range of the function g is also equal to domain of function f. Therefore, f of g exists. Right? So f of g is written like this, and this is the argument. Right. Now the function f of x will be twice x plus 3. So replace this x by the function g of x. Replace the x by the function g of x. G of x is x minus 1. Then you will get the answer 2x plus 1. Right. Now based on this example, you can see here that f of g or f by g is not equal to g by f. So this in general composite functions between two functions, uh, if you change the order, they will not match with each other in general, but in particular cases, in special cases, sometimes, where very rarely, f by g will be equal to g by f. Okay, we'll look at another example. Now in this example, you can see here that f of x is 2x squared. F of x is 2x squared. Now only the rule is given here. In this example, only the rule is given. You have to find the domain and range of these functions. Now for function f, you know, you can put any real number as the input, because this is a quadratic function, one of the simplest cases. For any x value, there will be a y value which is defined as the range of the function. You can see here that the minimum value for the function f will be the 0 when x equals 0, and all the other values will be positive real numbers. So therefore the range of the function will be r0 plus. For the function g of x is a straight line, so the domain can take any value from the real set, and so the range will also equal to the real set. Right? Now look at this r of f. This is the r of f. We'll take another different color. Right? This is r of f. R of f will be r0 plus. And the domain of g is the set of real numbers. So definitely r0 plus is a subset of the set of real numbers. So g by f will exist. In this case, g by f will exist. Now how do you find g by f? G by f is written as this. So the argument or the input of the function f of x will be x here, right, twice, and this will be the input squared. Now you have to this is the input of the function. What about g of x? G of x, for g of x, input will be this plus 1, right? Now when you take f by g by f, the function f will be the input, not the x. The function f will be the input. Now what you have to do is you put the function f and replace the x from the g of x. So in this case, you get a simple function, a simple quadratic function, 2x squared plus 1, right? 2x squared plus 1. Now let's see whether f of g exists. Now for function f by g to exist, you know that the range of the function g should be a subset of the domain of the function f. Now what about the range of the function g? Range of the function g is set of real numbers, and the domain of the function g f is also the set of real numbers. Now in this case, they are equal to each other. Therefore f of g or f by g exists. Now how do you find f by g? You simply replace the input here, the input of the function f by g of x. So g of x is in this case x plus 1. When you input this, you get this as an output, right? What does this mean? If we have an input x, the output would look like this of the two composite functions. Right. So we'll look at another example. Example 11. This is a special case. You can see here the function f of x is written as minus 2 over x squared, right? So how do you find the domain of this function? You know that domain should not include any value which will result in a division by 0, right? Division by 0. So you have to exclude any value that will make the function divide by 0. So how do you find the domain here? You have to exclude 0. X equals 0 should be excluded, so x should not be equal to 0, right? So I have written it here in this way. This is another way that you can write this, right? So you can select any real number, but you have to exclude 0. So this slash, this part will say that will mean an exclusion of an element. So in this case, 0 element is excluded from the domain F. What about the range of F? In the range of F, you know that if you apply any x value, whether it negative or positive, definitely the function will be negative because of this negative sign. For any positive or negative x values, the result or the range will definitely be less than 0, right? So it is written here like the negative values of r, you cannot include 0 here as well, so you exclude the element 0 in this case as well. Now the function g of x is defined as the square root of x. This is defined as the square root of x. Now you know from the basics, you cannot include any negative values for x. You cannot substitute any negative values for x. So therefore the domain of G should be only the positive real numbers including 0. In this case 0 can be taken as well. So it is written here, the domain of G will be positive numbers including 0, and the corresponding results will also be the same. I think you remember this square root function. The range will also be all the positive real numbers including 0. Now let's see whether G of F exists, right? We'll see. G by F. If G by F to exist, you know that the range of the function F should be a subset of the domain of the function G. Now when you look at the range of the function F is R inverse excluding 0, right? R inverse excluding 0. What about the domain of G? Domain of G is R plus 0, plus to 0. So domain of G includes all the positive values. Range of F includes all the negative values, right? All the negative values. Therefore there is no intersection between these two sets. That means no common elements. At least there should be common elements, so we can redefine the set. But in this case there are no such elements, no common elements. Therefore this is completely, RF is completely not a subset of D of domain of G. Therefore G by F does not exist. It doesn't exist, right? Sadly it does not exist. Now let's see what happens if we were to find f by G, right? The function f by G, which means the G comes first and function f comes second. So in this case you can see here what is the range of G. For that to exist, the range of G should be a subset of domain of the function f. So in this case the range of G here being so the range of G, what is the range of G? Where's the range of G is R all the positive values including 0. This is the range of G. What about the domain of F? Domain of F is all the real numbers excluding 0, excluding the element 0, right? Now you know that if we have instead of this, if we have only the set of R, definitely it will be a subset, right? It will definitely be a subset. But in this case the problem here being 0. For element 0, does not exist in this set. So there will be an outlier. 0 element is an outlier, therefore this is not a subset of the domain of F. So this due to this 0, only due to this 0, F by G does not exist. It doesn't exist, right? This is a cross mark, not X. Right? But as I said earlier, if you are asked to find F by G somehow, you can check whether it has any common elements, if they have any common elements. Now if we exclude 0 from domain of G, this is the domain of G. If somehow we exclude the element 0, then definitely domain of G, exclude from the domain of G, the range of G will be only the positive real numbers, because there will be no element. Let me show it here. So this is the function x, g of x, right? So if you apply x equals 0, the answer will be also 0, right? So there will be element 0. But if you exclude 0, the range will not include 0 as well. So we will only have the range of G, only the positive real numbers. Now in this case, range of G is a subset of the domain of F, which means F of G exists, right? So these are special examples. We will look at several other examples in the discussion, so it will make clear to you. If you don't understand this, please ask any questions during the discussion this week. Okay, I think that's it for this lecture. So this could be the last lecture of this series. I think we can start classes from July month. So okay, so thanks for listening. If you have any questions, please let me know.